A lot of logarithms, also including the equal sign, which means we're going to be solving for x for all these. Example number 1, log base 5 of x plus 2 is equal to 3. Okay. We're going to use the idea. It's an inverse property that we talked about a few days ago, probably a couple of weeks ago. And it's the idea that if we have a base raised to a log with the same base, so notice the b's are the same, what was this expression equivalent to? What does it equal? Well, it's whatever your of was. So the of was x, so therefore that's the idea. The other idea behind it is if I give you 3 is equal to 3, you would say that's an equivalent statement. That's true. We could multiply both sides by 4. That again would be true. We could add a to both sides, and that would be true. Okay, so we know how to do all of those equivalency properties. We could even do this. We could say 3 to the second is equivalent to 3 to the second. Okay, so raising it to a particular power is also true. But here's going to be the key for today's lesson. Suppose I want to create a base and raise it to whatever that expression is. If I choose my base to be 2, would that be equivalent? Yeah. If I choose a to the third is equivalent to a to the third. Okay? So this is the template that we're going to use for the majority of the problems today. It's very different. It's not how we would like to see it. We haven't seen it this way very often. So what we're going to do for 1a is we're going to take the expression on the left and we're going to throw it up into the exponent. And we're going to do the exact same thing on the right side. We're going to take that 3 and we're going to throw it up into the exponent. So the question becomes, what do we want our new base to be? Because I can let it be anything. You know, I could let it be a coefficient or I can let it be a variable. But we obviously want to pick the right values so that this thing can simplify for us. What do we want it to be? Anybody see it yet? We want it to be 5 because notice our base here is 5. And if we choose 5, then the base and the base are the same, so it's just equivalent to whatever the x value is. Okay? Or the of, sorry. So we want to use 5 because now the left side is equivalent to what again? Well, whatever your of is, x plus 2. 5 cubed is going to get us 125. And now we're looking at something much, much nicer. Subtract 2 to both sides. X is going to be equal to 123. Let's go ahead and look at part B. We have log base 8 of x raised to the third power is equal to 2. Step number 1, it's what we typically do. It's taking that exponent and bringing it down in front. So there it is. Now what do you suppose we want to do? Because again, the idea is we want to solve for x here. So we got to get rid of this 3 and we got to get rid of this log base 8. So the next thing we want to do is get rid of that 3. There it is. And now let's go ahead and use this property again. So we want to create a base. And we're going to take both expressions on the left and the right hand side and we're going to throw them up into the exponents. So So over here we got to the 2/3. Over here we got log base 8 of x. And what is that new base that we want to create? It's going to be 8 again. 8 and 8. So what is the left side equal to again? X. What's the right side equal to? Well, it's 8 to the 2/3. So now we got a little bit of work to do. We are going to review a property, which is what I meant to put up here. If we have a raised to the m over n, and I decide that I want to write it in radical form, the a went inside the radical. What did the m represent? That was our exponent. You're right. Okay? So exponent. And what did the n represent? Well, that was your root. So let's convert this expression to radical form. X is equal to square root of 8, and I shouldn't say square root, it's actually the cubed root, right? Denominator is my root. Raised to that numerator, which is 2. What's the cubed root of 8? 2. 2 squared is 4. Okay so far? Let's take a look at C. They give us an equal sign, so the directions are to solve. We need to solve for x. Now this one actually turns out to be much easier than what it appears to be. We are going to use this idea right here. You know, we had the log, we started out with the multiplication and then wrote it as a sum. Now we're going to take the sum and we're going to write it as multiplication. So, log x times the x minus 1 as a quantity, and the log of 6. And the good news is for us is that if I have the log of a, is that equal to the log of b, what do I know is true about a and b? They're equal. So, if you have a log of something is equal to a log of the other something, then those two somethings are equal to one another. So essentially the logs cancel each other out. That's good. Distribute, set it equal to 0. Factor. And those are the two solutions that I come up with. Now let's take our calculator. If we check these answers and we plug them back in, take the log of -2 for me. And what do you get? Error, domain error, syntax error. We get a lot of those, right? And basically what the calculator is telling you is that you cannot plug in that negative value. So the conjecture that we make, can we take the log of a negative number? No. So, we derive the -2, it does not work. So the only one we have. What would we call -2? Very good. Extraneous solution. Derive a solution that does not work. Last one. We talked about this, the log of a equaling log of b. If that's the case, then this. I should use my if-then statements. If this, comma, then we can say this. Do you suppose that would work for inequality symbols? You bet. Therefore, if we have the log of a is greater than the log of b, then a is greater than b. I believe the textbook used the less than sign, but it doesn't matter either way. If the log of A is greater than the log of B, then A must be greater than B. So the last one, then we'll practice some of these. We have solve the log 12x minus the log of 4 is less than log of 25. Thoughts on what we'd like to do here to begin with? Let's see if we can't condense it down on the left side. Yeah. You know, we used the addition property already. Can we use the subtraction property? Yeah. And if we subtract here, what are we doing on the inside? Well, we're going to divide. Again, it's the reverse order of what we're used to. We're used to expanding it out, now we're condensing it down. And the reason we want to do that is because notice now we have the log of both sides. So now the logs cancel each other out. This is working out very nicely. 12 over 4, even that reduces down for us, so now we're down to this. And there it is. Beautiful. Practice problems are going to be A, B, C, and D.